Guys and gals of all ages, juniors, freshmen, sophomores, we're heading into a new unit, Unit 9 with Coach Goo. Another fun-filled, action-packed, flipped geometry classroom video. So we're starting Unit 9, and this unit, we just finished triangles, the three-sided polygons. Now we're moving into quadrilaterals. You know what a quadrilateral is, guys? Quadrilaterals are four-sided polygons. Quad means four. Quadrilateral, four-sided polygon. Quadricep, four muscles in your leg. That's the quadricep. Okay, anyways. So today we're going to be learning about polygons and their angles. So there's a lot of stuff you just have to remember, but we'll go through it to try to make some sense of it all. So polygons and their angles. Now for these following formulas, there's a lot of formulas in here, and n, we're going to use the letter n to represent the number of sides of a polygon. So for example, look at this. Oh, that's not a highlighter. So right here, n equals the number of sides of the polygons. For example, n would equal 4 for a square because a square has 4 sides. What would n be for a triangle? It would be 3 because there's 3 sides. And what would n be for a pentagon? It would be 5 because there are 5 sides. You got that? Yeah! Okay, moving on. So, first we're going to find out the sum of the interior angles of a polygon. Interior angles of a polygon are the angles on the inside of a polygon. So for example, look at the triangle right here. The interior angles are the angles on the inside. So that would be this one right here, and this angle over here. Now the sum of the interior angles of a polygon is going to equal, let me highlight it, 180 times n minus 2. Remember, n is the number of sides of polygons. What's the total number of degrees inside a triangle? You guys should know this. 180. Did you say that? Yeah, high five. Boom. 180 is the total degrees in a triangle, right? Well, what is n for a triangle? It's 3 because there's 3 sides in a triangle. Now our formula says the sum of the interior angles of a triangle is 180 times n minus 2. So for a triangle, watch this. 180 times n. N is 3 for a triangle, right? So 3 minus 2, that's 180 times 1 equals 180. Exactly what we already know. We know a triangle has 180 degrees, and this formula even works with a triangle. So this formula is always going to work with different polygons as well, even for a square. Boom, bam. Oh, I guess those are all same sides, same angles. Next, moving on, how to find the measure of an interior angle of a regular polygon. What is a regular polygon? A regular polygon is a polygon where all the sides are congruent. For example, an equilateral triangle where all the sides are congruent. That's a regular polygon. A square where all the sides are congruent is a regular polygon. A rectangle would not be a regular polygon because all the sides are not congruent. They're not equal lengths. All right, so how are we going to find the measure of an interior angle of a regular polygon? Here's our formula, 180 times n minus 2 over n. So all you really have to do is find the sum of the interior angles. That's right here. Remember, you're going to find the sum of the interior angles. Then you're just going to divide by the number of sides. So for a triangle, remember, a regular polygon for a triangle would be an equilateral triangle. What is the measure of each angle in an equilateral triangle? We know it's 60 degrees. And let's check it with this formula. 180 times n minus 2 divided by n. N is 3 for a triangle, right? N equals 3. So let's plug in the 3 for n. 180 times 3 minus 2 divided by 3. 3 minus 2 is 1, so this is really 180 times 1 divided by 3. That's just 180 divided by 3, which equals 60. And that's the 60 degrees that each angle in an equilateral triangle is. So it works. All right. Now moving on, the sum of the exterior angles of a polygon. So if the interior angles of a polygon are the angles on the inside, on the interior of a polygon, what would be the exterior angles of a polygon? That's going to be the angles on the outside. So for example, take a look at this triangle right here. I'm going to label some angles. So we have this angle right here. I'm gonna highlight it for you with a red circle. Look at this angle right here. The exterior angle would be, I'm gonna draw it in orange, or I'm gonna draw it in green actually. It's gonna be this right here. Okay? The exterior angle is gonna be that right there. Pretty much, how do you find that? You're just gonna draw a straight line off a side of the polygon. So you see how this is a side, you just extend the line, and then right here, that's an angle. So the exterior angle is the other side of that. So like that. So for example, if this angle right here is 60 degrees, what is the exterior angle? The exterior angle, you would just extend this line, bam, and it would be the rest of whatever this line is, which would be 120 degrees, because remember, a straight line is always 180 degrees. So we already have 60, and then the exterior angle, 120, adds with the interior angle to make 180. So let's see a formula to find the measure of an exterior angle of a regular polygon. So if you have a polygon where all the sides are the same, so let's look at the triangle again, bam. All the sides are the same, so it's a regular polygon. And now this is an equilateral triangle, so all the measures are 60 degrees. How would I find the measure of an exterior angle? I'm going to take 360 and just divide it by the number of sides. So in this case, n is 3 for a triangle. So 360 divided by 3 equals 120. And just like in the example that I did, where look, if I extend this angle, bam, what is the exterior angle? It is 120 degrees. So you can see that it matches up. It works. Okay, so finally, in the last step, it says the relationship between the interior and exterior angles of a polygon. An interior angle and its adjacent, that means the one that's right next to it. Adjacent means right next to. Its adjacent exterior angle are supplementary. That means adds to 180. And as you can see, that's how we've already defined in all these pictures so far. Look at this. The exterior angle right here, there we go, right there, plus the interior angle, they always add up to 180. So the 60 plus 120, that equals 180. So these are just things that you have to memorize. So let's do our best to memorize it. And let's do a few examples to see how these formulas actually work. Alrighty, so in this chart down here, we're assuming that all the polygons are regular. That means all the sides are congruent. So in this first one, it says a pentagon. So I'm going to draw a regular pentagon where all the sides are the same. So that means like I'm drawing the congruency marks. All the sides are congruent. So let's fill out our chart. The number of sides, that's n. Remember, n equals, what is it for a pentagon? How many sides does a pentagon have? 5! That's right, n equals 5. Next, sum of the interior angles. Look above, see what the formula is? The formula is 180 times n minus 2. N is 5, so 5 minus 2. That's 180 times 3, which is 540. And remember, it's degrees because it's an angle. Next, the measure of an interior angle. How do we find that? You take the sum of the interior angles, and then you're going to divide by n, the number of sides. So 540 divided by 5. And that's going to give you 108 degrees. So the measure of a single interior angle in a regular pentagon right here, the interior angle is going to be 108 degrees. Now, the sum of the exterior angles, this never changes. It's always 360 degrees. And lastly, the measure of an exterior angle in a regular polygon. You're just going to take 360 and divide it by n. So what's that going to be? What is n here? It's 5. So 360 divided by 5 is 72. So 72 degrees. And now look at our picture. Let's just make sure that's actually right. Remember, exterior angle just extends off and adds together with the interior angle over here to be 180. If part of this is 108, the total is 180, what would this exterior angle then be, just based on our picture, not with our formula, just based on the picture? It would be 72 degrees. And that matches up with our formula, so we can see that it's right, it worked. Oh my goodness. All right, so now I'm gonna do the decagon with you. I'm not gonna draw a decagon because that's a little too much, probably a little too difficult. But let's just fill out the chart. Decagon, number of sides, 10. That's what deca means, 10, decade, 10 years. Decagon, 10-sided polygon, 10. All right, sum of the interior angles, 180 times 10 minus 2, because it's n minus 2. That's going to be 180 times 8, which is 1440 degrees. Wow, that's a lot of degrees. Next, to find the measure of the interior angle, we're going to take that 1440 and just divide it by the number of sides. I don't know why I put a degrees there, which is 10 sides. That's going to be 144 degrees. Nice. Sum of the exterior angles, that never changes. It's always 360 degrees. And last, to find the measure of an exterior angle, we're going to take that 360, divide it by our number of sides, which is 10, and that's going to be 36 degrees. Now, just to check, my interior angle and my exterior angle should add together and be 180. So these two numbers right here, 144 plus 36 should equal 180. Does it? Yes, it does. It checks out. We got it. So you guys fill out on your own the hexagon and the 15-gon. Not sure what that's actually called. I'm going to do the problems on the left. You guys are going to do the problems on the right. So here we go. Now, we got to read carefully and try to see what it's saying to us. So the first one says, 5 angles of a hexagon. Hexagon, keyword. How many sides does a hexagon have? 6. So I'm going to go ahead and label n equals 6. Measure 119, 129, 104, 139, and 95. What is the measure of the 6th angle? So we need to find the total sum of the angles inside a hexagon. How do I do that? The formula is 180 times n minus 2. N is 6 right here, so 180 times 6 minus 2. That's going to be 180 times 4, which is going to be 720. So my total degrees in the hexagon is 720. They already gave me 5 of the degrees, so I'm going to add all those 5 numbers together. 119 plus 129 plus 104 plus 139 plus 95, and I forgot how to write equations like this, so I don't need all these plus signs. All right, add that together. That's going to be 580. Actually, I'm just going to 586 degrees. And then to find that last angle, I'm going to take 720 and subtract that 586. So then that's going to give me 134, and that is my missing angle. Boom. So now I'm going to do this bottom left question, okay? If the exterior angle of a regular polygon measures 9 degrees, so 9 degrees, okay? And then they said exterior angle of a regular polygon. So we should have a formula for that. How many sides does the polygon have? Well, what's the formula to find the exterior angle of a regular polygon? You take 360 and divide it by n. N is the number of sides, okay? And that's going to equal 9, because they told us that the exterior angle measures 9 degrees. This formula gives us the exterior angle. They told us the exterior angle is 9. So I can set it up like this. Now, we could just cross multiply. So instead of writing 9, I'm going to put 9 over 1. Cross multiply. Bam, bam. And that's going to give you that 9n equals 360. Then we just have to divide both sides by 9. And n equals 40. That means my polygon has 40 sides. Oh my goodness, that's crazy. All right, guys, that's the end of these notes. So it's a lot of memorization. You just got to get used to it, but I'm sure you'll do fine. And that's the introduction of the start to the world of quadrilaterals. So see you next time.